In this short video, we are going to discuss about or have an introduction to closed loop control systems. So this will be our main topic for this short video. Here you can see a block diagram, a generic block diagram of a linear control system in the closed loop form. You can see that there are a given number of blocks. For example, we have GT0 over here, we have HP of S here, HT of S, GC bar, GP, and GT. Each one of these blocks are indeed representing us a kind of system. Okay, so they could be in the form of a transfer function as well, as we will see it later. The main thing to keep in mind here is that we have a closed loop system. The closed loop system means that we are having a kind of loop here. So we are measuring the output C using an output transducer, and then it is being compared with the input reference signal. Then the difference, which is the error, is applied to the controller, and afterwards the output of the controller is given to the process, which could contain the actuator as well, and then it will generate us the output. Over here we have one main output signal, which is C, and one main input signal, which is R0, or the reference signal. However, we also have two other inputs, DH and NH. DH is the disturbance and NH is the noise. You can see over here that DH is used as the input to the HP of S block, and HP of S is indeed representing us the process uncertainties and the disturbances. Okay, we will talk later about what the disturbances are and how the process uncertainties are defined. But for now, you just keep in mind that HP is representing a part of the system which is dealing, or which is considered for dealing with disturbances and the process uncertainties. On the other hand, HT OS is showing us how the noise on the transducer is happening. So we are measuring the output with a sensor, with a transducer. So we will have the actual signal measured, but there will be some additional noise on top of that. And to represent the behavior of the noise, we will refer to HT of S as the underlying transfer function. Here you can see an example of a closed loop system given in the form of blocks, but we don't have the transfer functions for each block. However, we are representing it with some symbolic image. This is the speed control of a DC motor system. You can see that we have R0 as the main input, which is the knob angular position. So you just turn the knob to the right or to the left, clockwise or counterclockwise, and then you determine in the desired speed that you want to have. Then there is the potentiometer, which converts this position, the angular position of the knob, into some reference voltage, which is shown as R bar over here. This reference voltage R bar is being compared with the signal which comes from the output of a sensor. Here a tachometer is used in order to measure the speed of the motor. So the tachometer is indeed attached to the motor, and it is giving us as the output signal the actual speed of the motor. This actual speed is being compared with the reference voltage, which is indeed the desired speed of the motor, and it gives us some voltage difference, which is actually the error between these two. We also here have some high frequency electrical noise, which is it is being added to the output of the tachometer. So what we compare here, our reference or desired speed with the actual speed of the motor plus some noise, which comes from some high frequency electrical noise. Then this error signal is generated, the difference between these two, and it is applied as the input of some controller. In this case, we have a PID controller. It will give us some control voltage, which will be applied to the DC motor itself. There will be some disturbance considered here in the form of a torque disturbance, and later we will see how this torque disturbance is affecting the behavior of the system and how we can deal with that. And finally, we will have the actual speed of the motor. Depending how the controller is designed over here, the behavior of the motor in terms of how fast it follows the changes in the reference speed or desired speed will be determined.